is the story of Willow Run, one of the Ford farms that virtually overnight became the largest aircraft plant that had ever been built. A story that now can be told in full. Here, before our security and freedom were challenged by war, boys were learning the trade of being productive and responsible Americans. They were taught to till the land and plow a straight furrow. Guided by farm experts, aided by modern machinery, the boys at the Willow Run farm planted, grew, and harvested the finest produce. In the early spring, they tapped the sugar maples, collected the rising sap, and took it to the nearby sugar house where it was converted to maple products. Then came the threat of war. The sugar house, the maples, and the farm were sacrificed to make room for a plant designed to produce one consolidated Vultee Liberator every hour. Thousands of skilled workers were employed, pouring 100,000 yards of concrete, erecting 38,000 tons of structural steel, setting 10 million bricks, fitting miles of piping, and running more miles of electric cable to operate the thousands of machines that were to be installed in this truly giant structure. The Army Air Forces asked Ford to undertake mass production of this bomber, in addition to other aerial weapons produced by the company, which included troop-carrying gliders, turbo superchargers, and the 2,000 horsepower Pratt & Whitney aircraft engine. This 80-acre plant was built in record time. In reality, it was made into two plants under one roof, a manufacturing plant and an assembly plant. The now famous Willow Run Airfield covers 1,434 acres and provides 280 acres of concrete runways and taxi strips, enough to make a two-lane concrete highway 120 miles long. And this was Willow Run's product, a giant flying machine for which the plant was so carefully tooled that it could produce one every 55 minutes. This is the Army Air Force's Liberator Heavy Bomber, the ship that made headlines and was affectionately known among flyers as the Lib. This great aircraft is 110 feet from wingtip to wingtip and 67 feet 4 inches from nose to tail. Powered by four 1,200 horsepower air-cooled engines, the Lib can carry 10 men, 4 tons of bombs, and 5,000 rounds of machine gun ammunition at better than 300 miles per hour at high altitude. The B-24, as it is officially designated, can fly 3,000 miles non-stop. And as the pilot signals the control tower and prepares to bring her down, we will soon see for ourselves how this modern miracle of mass production has been performed. Okayed by the tower and lined up with the runway, we are bringing in 20 tons of bomber at better than 100 miles per hour. On solid concrete. The pilot again calls the control tower and is assigned a position on the apron. And as we taxi to this berth, we pass just part of a day's production waiting to be tested by Ford pilots. Wave our pilot to his position, and we are grounded at fabulous Willow Run. At the entrance to the administration building, 1 mile away from the landing apron at the other end of the plant, this plaque proves that the Army Air Forces and Ford were ready when war came. Dedicated June 16th, 1941, 6 months before Pearl Harbor. In offices of the Army Air Forces and in that of the Ford Superintendent, a close check was kept on the movement of all bomber assembly lines with this master board, numbered movable models show the step-by-step progress of the nearly 100 bombers which were always progressing down through the plant assembly line. People flooded in the gates of Willow Run summer and winter, by day and by night. At one time, 42,000 of them. They made up the ranks of the bomber plant's production force. To teach these workers how, a $500,000 school was built adjoining the plant. More than 50,000 workers were graduated in from 1 to 10 subjects by this school organization. To do this vital job, Ford had to provide hundreds of instructors to teach more than 50 courses. Workers learned about the complicated aircraft hydraulic system and the mysteries of aircraft electronics. Cutaway engines served to illustrate installation and service details. Bomber and hour production made necessary the erection of a detached warehouse covering 11 acres to house and handle raw materials. In this vast space, 785 totally different items were stored. There were enough materials here and in the plant at one time to build 1,000 Liberators. Here you would find sheet aluminum, aluminum bars, coiled aluminum wire, and virtually every other known form of this lightweight metal, for 85% of a Liberator's 20 tons is aluminum. This was the first step of construction. Aluminum sheets were cut into proper sizes for handling in the plant's presses and forming machines, such as this great battery of presses which stamped out parts for the B-24. Some of these, the same presses Ford uses to make bodies and fenders for automobiles, were loaned to Willow Run. Because of the great variety of parts that go into a bomber, nearly 15,000 dies had to be constantly rotated through these presses to maintain a sufficient stock of parts on hand. Before these aluminum sheets were fed into presses, they had to be sprayed with a lubricant to prevent scratching and to help the metal flow in the dies. In this operation, 3 presses are seen shaping a wing bulkhead. Because of the wing taper, 57 different shaped and sized bulkheads were made for each wing. These presses soon produced enough of this size for many ships, after which the dies had to be changed. So the die changing operation went on continuously. Since these planes were to be flown over salt water, in the tropics, far north, all over the world, individual parts had to be treated to protect them from the elements. Racks like these dip 52,000 shining pieces, plus 4.5 tons of rivets every working day. And speaking of rivets, 400,000 went into every Liberator, and these too were produced at Willow Run. This plant produced more than 400 sizes and 13 varieties of rivets, carefully checked by inspectors. In sharp contrast to small rivets are these 250-pound landing wheels shipped in, ready to install. Just the tube of this tire weighs more than the complete tire and tube on the average family car. The wings and fuselage took thousands of feet of stringers, the ribs of the body, and these were shaped on miniature rolling mills such as this. Each roller adds a bend in the stripped aluminum. Then the length is sliced off. After treating, stringers went to punch presses, where as many as 312 holes were punched with one stroke, through which rivets later held the aluminum skin. Practically everything in a bomber had to be curved in one direction or another. The revolving action of the die bends the metal to the needed shape. This peculiar looking operation was typical of many at Willow Run. At this station, heavy stock was rolled into a circular track for a power gun turret. And this later was machined to fine tolerances so that the guns could swing smoothly and swiftly in combat action. Aluminum tubes made up the arteries of the Lib. These tubes carried gasoline, oil, hydraulic fluid, oxygen, compressed air, fire extinguishing fluid, steam, de-icing solution, screening smoke, and antifreeze to various parts of the ship. More than 1,700 different tubes were installed in each B-24 to feed the 12 different control systems. Straight pieces of tubing were cut, bent carefully, flanged, degreased, treated to prevent corrosion, prepared with proper fittings and inspected. Each was identified with colored tape. Instead of putting individual tubes into the bomber, Ford's mass assembly technique called for making them up into clusters, which were made in special jigs and fitted into the bomber in entire units. And here you see workers assembling the pre-bent tubes into one assembly unit. These clusters, assembled with other sections, made up the bomber's complicated plumbing system. Basically, Willow Run's manufacturing system was like that of the Ford automobile plants. This was the key to the secret of building one bomber every hour. This chart shows how Ford production men cut up the Liberator into major assembly sections. 1, the center wing. 2, the nose. 3, the aft fuselage. 4, the engines. 5, the tail. And 6, the outer wings. And these were handled very much like automobile assembly lines, where cars are also divided into major components: the frame, the engine, the wheels, and the body, all mated on the final assembly line. Like the automobile, this bomber started with small parts being fastened together, such as by spot welding. There are no sparks in spot welding, the metals being fused by pressure and an electrical charge. This welder makes 300 spot welds a minute, so close together that they make a leak-proof seam. Applied to aircraft manufacture, Ford's spot welding technique saved 35,000 man-hours of labor per month and replaced 15,000 relatively heavy rivets in every bomber. Parts that do not lend themselves to other methods of assembly were welded by gas, and here these men and women use gas torches to join parts. Gas welding of aluminum is a highly specialized job, and scores of welders were trained in the Willow Run School. Plenty of special tools like this pressure riveter were designed for use in this work. Small assemblies for planes required much handwork, as demonstrated by this use of an air drill on one assembly phase of the tail turret well, and more dramatically shown by the building of the pilot's control column. Because of the relatively few units required to meet bomber-an-hour production, it would not have been practical to devise a moving conveyor line for such assembly operations as these. Assembly work was, of course, simplified by precision machining operations, by which formed and cast parts were shaved down almost to perfection with allowable tolerances running from only 1/2 of 1,000th of an inch to 15 thousandths. Among the small sub-assemblies, some of the more interesting originate in the plexiglass section, where windows of strange shapes were made of this light plastic. After being soaked at 256 degrees, transparent plastic becomes flexible and can be readily shaped to needed patterns. After cooling, this particular piece becomes part of the bombardier's enclosure for the nose of the ship. Dipped in this solution, it required a protective coating to prevent scratching during handling. This coating was removed later. And here workers are shown fastening aluminum skin to a stringer assembly to make a most important part of the bomber, the center wing section. Like the frame frame of an automobile, the center wing is the backbone of the Liberator. It carries the load of the 4 engines, the gasoline tanks, the bombs, the fuselage, and the landing gear. The spar is the main beam that runs the entire length of the center wing. The whole wing is built around it. By breaking the center wing down into sub-assemblies and by using mass production fixtures such as these, Ford cut the cycle time for building wings from 19 days to a matter of hours, from 11,414 man-hours of labor to just a few hundred. When the sub-assemblies were completed, they were swung by crane to big 27-ton vertical fixtures, the massiveness of which ensured rigidity. After the spars were in place at the bottom, bulkhead and stringer assemblies were lowered and fastened together to form the main structure of the wing. Aluminum skin was then riveted to the outside, and another center wing assembly was completed. The completely assembled wing section then moved off through the air to the next operation. Faced with the possibility of a bottleneck in the machining and milling of such a large section as this wing, Ford engineers found an idea which they had used for many years in making automobiles. They designed a brand new machine shop combine known as the Final Machining Unit. While the wing was held firmly in position, it was attacked from all directions by drills and milling tools. Simple illustration is offered by this multiple drill used to machine Ford V8 engine blocks at the Rouge plant. Note that the drills come in from all angles and drill many holes at one time. So it is with the Final Machining Unit. Many machine operations were performed at the same time and in exactly the same position on every wing. This illustrates why every part of every Ford-built Liberator is exactly like every similar part, and shows why these parts have been interchangeable from ship to ship all over the world. Cranes fed the completely machined wings to twin furnishing lines, each of which was about a city block long. Here, women workers began installation of the incredibly complicated wing wiring system. Also, the tubing clusters you saw being assembled in another part of the plant. And the 4 turbo superchargers, actually turbine pumps, which force air to the 4 engines, increasing horsepower and enabling the ship to fly higher where the atmosphere is thin. These superchargers are exhaust-driven turbines, the rotors of which speed up to an incredible 26,000 revolutions per minute. The landing gear was installed here, hooked up to its controls and tested to be sure it retracted. And so we now see the center wing section, the chassis of the bomber, completely assembled and on its way to the 4 final assembly lines. It is ready for mating to the other main sections of the bomber, which have been assembled in other parts of the vast plant. The nose section was next with its vital flight instruments, cabin for pilots, radio man, flight engineer, navigator, and bombardier. This section is the nerve center of the ship. The nose section started out with this ribbing in which the woman worker is installing a window frame. Aluminum skin then could be riveted to this ribbing to form the outer wall. Side panels for the nose, consisting of more than 500 structural parts, were attached to a conveyor and moved along an assembly line. Each of these women workers had a certain job to do in furnishing this wall with its necessary equipment, including more than 1,000 different parts. This method of assembly saved time and money because this work would take much longer if done in the limited quarters of the bomber after assembly. Here on these assembly lines, the workers could do their job quickly and easily. The pilot's floor, controls, and instrument panel was put together on a 400-foot, merry-go-round type of assembly line which revolved very slowly and which consisted of 30 stations. This obviously very intricate and complicated assembly job consisted of 190 separate installations, each of which had to be a sub-assembly with a maze of detail within itself. Complete with its surrounding framework, the pilot's floor was then lowered into a special mating fixture. A crane then brought the complete sidewalls over to the fixture and placed them in position. This wall was furnished with a great deal of equipment, including an electrical harness consisting of more than a half-mile of cable. This fixture was so built that both side walls could be slid over against the framework that supported them. Then the entire unit was fastened.